Hello, I welcome you all to this another interesting screencast. The problem reads the 400-pound cylinder at A is hoisted using the motor and the pulley system shown. If the speed of point B on the cable is increased at a constant rate from 0 to VB equal to 10 feet per second in time t equal to 5 seconds, determine the tension in the cable at B to cause the motion. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. So we're going to use kinematics here, equations of motions, which is also dynamic equilibrium as well as static equilibrium. Alright, so let's use the kinematics here so that we relate the position of A with respect to B. So let's have this as our reference. Okay, I'll choose this particular point here, and then for this other one, for A, that one like so. So let's call this as so these are datums. Let's call this as SB. This is SA. So let's write the equation that relates to the length. Of course, we've left these other parts which are just constants. So we are going to have 2SA plus SB equal to L. Okay, therefore we'll have 2BA plus VB equal to 0. Yes, and then we'll have 2AA plus AB equal to 0. Alright, and then here we know that our VB is equal to 10 feet per second, and therefore from this equation we have the following. Making VA subject to formula, this is just equal to VB divided by 2 minus, which is just equal to 10 minus divided by 2, and hence this is just minus 5 feet per second. Okay, 5 feet per second, which just means initially, of course, our reference was like so, and then this one was like so. Okay, but of course in the opposite direction, meaning it's going up. So we have our VA equal to 5 feet 5 feet per second, and it's going up like so. Okay, so are we done? So once we've done this, we know the velocity. We just need to use this velocity to compute the acceleration. So let's do some. So we have been told that the acceleration, you've seen this, the speed, if the speed at point B on the cable is increased at a constant rate, so acceleration is constant. Acceleration is constant. Therefore, we can use, we want to find acceleration here. If VB is increased, I mean the speed is increased at a constant rate from 0 to VB equal to 10 feet per second in t equal to 5 seconds. So let's find the acceleration. So I'll use this equation, v is equal to v naught plus at. Okay, where our v naught is just equal to 0. Our v is equal to va, which is equal to 5, and our a is what we are looking for. Our time we've been told is equal to 5 seconds. Therefore, this just becomes 5 is equal to 5t, right? 5a. Okay, and our acceleration, which is equal to AA, is just equal to 1 feet per second squared. Okay, and it's also going up. So we found the acceleration. So with this acceleration now, we need to write down the equations of motion. So let me just cut this. I just show the tension, this in this. Okay, let's do so. Once we do that, then we are going to have something like so. So let's write down the tension. So we'll have tension there like so. Okay, and then there like so. And then we'll have tension there like so. Okay, and then they are like so. They are like so. And then we'll have they are like so. Alright, let's label this. So here we have T. Okay. Let me start from this. So we have T, which is T here. And then here it goes round the pulley, we'll have a T and a T. And then here we're going to have 2T, which is equal to that like so. Okay, then we have some weight here. This is the weight, and is equal to W equal to mg, which is just equal to, here is already given, is 400 pounds. Okay, of course this is going upwards. Okay, this is upwards. We have to draw the kinetic diagram. We are moving up. This is moving up. Okay, which is ma. So let's write down the equations of motion. Let me just demarcate this. I demarcate it somewhere there like so, and then I bring it down. Alright, so let's write down. So what do we have? Mind you, we are looking for T, the tension. So now so we're going to have 2T minus W is equal to ma. So 2T minus W, which is just 400 pounds, is equal to M, and M is just 400 divided by 32.2, right? Weight divided by G. Okay, is that fine? Great. Then times the acceleration, which we found equal to 1. We said our acceleration A is just equal to 1. Remember this one here. Alright, therefore our T is just going to be equal to we have 400 divided by 32.2 plus 400 divided by 2. So we have T equal to 206.21 pounds. Okay, so we have 400 divided by 32.2, goes times 1, then plus 400, which is the weight, Okay, then divided by 2. So we have a 206.21. So this is the tension. This is the tension that we're going to experience in the cable at B. So I hope this particular video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye. And see you in my next screencast.